I want to create a forecast measure. So assume that I'm creating a forecast measure from Jan 2026 to December 2026. So I'm going to go ahead with model forecast. So forecast measure is a visual measure that helps you to enhance your semantic model's data by creating the potential or predicted forecast values so that you can use those values to benchmark with your actuals or even take planning decisions. Now, this will be, let's say, the first forecast that I'm going to create. So I'm just going to call it, okay, MSTL. You're going to run the MSTL forecast first, okay? And I want to link it with the existing past measures for the close period. So close period forecast will be created, but it will only refer to the actuals because we don't want to create forecast for the close period. There is no way we want to do it right now because we are not going to check this, right? As business users, all we are interested is to predict the future. All right. Next is let's click on create since the open period value should be data input. And I would like to use this so that I can make changes or my users can make changes with the data for the forecast measure. I'll click create and this looks good. Let me use revenue actual and copy the values for 2026, referring the values of 2025. So I don't have a blank measure there, right? So I'll click on save. That should be okay. Now for the close periods, I'll just uncheck this so I don't see the close period forecast. This is my 2026 MSTL. Right now, the MSTL forecast is not predicted because we started with the values coming from the past period. So you see the values are exactly matching. Now what I want to do is after clicking save, I would like to run an MSTL forecasting algorithm. I'll let's say I'll go ahead with the total. I have the predict button in the model tab. Click that. This is staying on grand total because we've selected the grand total row. I can actually go to any specific level based on the number of dimensions that I have, and I can only forecast that specific dimensional, intersection. So this is a very unique feature that adds a lot of value if you really want to focus on a specific, let's say, row, and then you want to run forecast differently on that specific row, right? But we'll stick to the grand total. And now this is the predict functionality that is clearly showing us very interesting elements within it. So we have the measure name, we've got the history date, the date range is 23 to 25, forecast date 26 December, Jan to December, and then we've got multiple configuration profiles that can be created. So you can rename profiles, you can create profiles. I will you just use one profile for now. I want to go with 90% confidence. So there will be the confidence level shown. So I do not want to go anything beyond, or let's say less than 90%. I want to stay in that range. And then I can bump up my values by directly putting the growth here. So any number that is predicted by the engine, it will be topped up with 10%, 5%, or whichever positive value that you want to show. I will not use it right now because we want to clearly bring out the numbers that is predicted by the system without any growth factor. Now, the most important point is evaluation. There are two types of evaluation. You've got bottom up evaluation and top down evaluation. The simplest difference between them is that for bottom up evaluation, every row will be iterated by the algorithm and every row will be used for predicting based on that specific dimensional intersected, or let's say that specific rows time, or let's say trend. So let's assume that for electric toothbrush, which is in personal care in New York, there will be a specific trend which is different than the trend of other rows. It will be treated individually, and then row by row, the forecast is predicted and the total is aggregated on top. However, for top down, the trend and the seasonality of the grand total is evaluated, and the output of the predicted value is spread and distributed based on the self weight of that specific measure. So let's go ahead with bottom up. Now, the interesting piece, which I mentioned earlier, I'm not going to put any coding or programming stuff on the screen. You have got algorithms to choose from, trend decomposition with MSTL, exponential smoothing. This is the ETS. This is the MSTL and ARIMA. So you go with MSTL for now for this example, and then you got your seasonality checks. Do you expect the data to have yearly seasonality or quarterly seasonality? That's based on your data. I'm aware of my data and I see that the seasonality is by year, not by quarter. But in case if you have both, you can select the quarter as well. Why is it not giving month? Because month is the last scale of our time dimension that we saw. That's why it will not look at the last scales, or it should never look at the last time scale as seasonality criteria. It should always go one hierarchy up. And that's the very interesting part of statistical equations. Now, here is fine with us. We just click on run forecast. All right. So what do we see here? We see a table with confidence ranges. We see the values for the period. If I scroll down, I see the past period, which is untouched. If I scroll up, I see a nice focus mode of my forecast, which is a preview. Historical range is shown in gray, confidence range is in light green, and your forecast is in darker green. So this is more like a blend of the Microsoft Fabric, let's say, color scheme. So that's your MSTL. If you are okay with this, go ahead and save the forecast. If not, you want to reconfigure, you can do it. If not, you can use the same configuration, make some changes with your growth factor, and then rerun the forecast. I'm okay with this. Let's save this. Select the measure to save this forecast. We have named it as MSTL. Let's save it. The date range is here. Looks okay. Let's click on save. So it predicts 77.7 million. Not bad. I'll just save this. Right, while it is saving, let me now look at how this has been distributed, nicely distributed to all the scales of time. I'm okay with this. I can further make changes with this. I can actually bump this up, let's say 5%. And the 5% delta is going all the way down, nicely distributed.